So welcome back everybody in the carnival of production. Please let the students know that so that we'll start the session. So let the students know that so that we'll start the session. So let the students gathered, right? Today we are going to consider a best topic of manufacturing, that is production engineering. Right, so how are you all? So mark your presence by liking the session or just comment down there. So mark your presence by liking there and comment down, everybody. So I welcome you back. This is Ravindra Thuve, faculty at BYJU'S Exam Prep. I welcome you back in the best possible session of metal cutting. We'll kickstart solving numericals here. So mark your presence by liking the session and comment on this particular below so that I'll get to know that who are joined, so that we'll have certain interaction and then we'll kickstart the session. So yes, Sandeep, good evening everybody. Today there won't be any theory. As I promised, there would be only a numericals, fundamentals and numericals that we are going to discuss. So welcome aboard, welcome back. So if you type something, that you'll come to know that there are so many students are there, live students are there. Are you all excited? Yes, so do I am exciting for this. Sandeep and rest of the students, just comment, yeah, hi, something, just write down there. So yes, Kiran Kumar, good evening sir, good evening. Yes, Kiran Kumar, good evening everybody. So very beautiful content is there as far as you is concerned. Be ready with the calculator, be ready with the pen and the paper. We have to solve. We are not here to waste the time, right? The time is money and money is time. I told you already that, right? Fine, so should I kickstart the session? So this is Ravindra Thuve, faculty at BYJU'S Exam Prep. I secured all India rank 79 in GATE examination 2010 and I am alumni of IIT Kharagpur. I am taking a lot of pride for that. So with Sandeep and Kiran and with Ranjit, thank you everybody. So we'll kickstart our session with the first question. Is it visible to everyone? Are you ready to solve this particular question? Yes, I hope so. Everybody's ready? Yes, we'll kickstart the session, right? What is that? In orthogonal cutting operation, the depth of cut is equal to 2 millimeter. Width of the cut is 15 millimeter. Cutting speed is 16 meter per minute. And the rake angle is exactly equal to 0 degree. The cutting force and the thrust force are given 1200 Newton and 800 Newton respectively, and the shear angle is exactly equal to 30 degrees. So there are certain data is given, write down the data, and the first question was asked, very simple, calculate average coefficient of friction. So we have to calculate friction value mu. What we have to calculate? We have to calculate value of mu, we have to calculate in this particular drama. And whatever the data given, you write down on that side, use the formula, calculate the answer and tell me that. It's very simple. So if I want to say that, sir, depth of cut is given, so I'll say that depth of cut is D and width of cut. But we know that when the depth of cut and width of cut is given, can I say that depth of cut and the width of cut, there are two values are given. Depth of cut and what? Width of cut. So I'll say that depth of cut is exactly equal to 2 millimeter and width of cut W is exactly equal to 15 millimeter. So can I say that in that case, depth of cut will become uncut chip thickness. Uncut chip thickness, that is T0. And width of cut will become what? The thickness or width of the chip. Width of the chip. Width of the chip will be represented by B. Width of the chip will be represented by B. Okay, fine. Cutting speed. Can I say that cutting speed VC is exactly equal to what? 60 meter per minute. Everyone has to solve this question. Everyone has to solve, right? Rake angle. Rake angle is 0. Alpha 0 is exactly equal to 0 degrees given. Neglecting the force, sorry, the cutting force and thrust force are given. What is cutting force? Cutting force FC is exactly equal to 1200 Newton and the thrust force FT is exactly equal to 800 Newton. Is it true? Yes. And we are interested to calculate this coefficient of friction. Shear plane angle phi is also given. Now you tell me that how to calculate shear plane angle phi. So we know that, sir, for calculation, sorry, coefficient of friction we have to calculate, that means we have to calculate mu. We have to calculate what? Mu. Mu is nothing but friction force divided by normal force. We can say that friction force divided by what? Normal force is exactly equal to mu. Okay, fine. But sir, no such data is given. Friction force is not given, normal force is not given, cutting force and thrust force is given, and rest of the data is given. Rest of the what? Data is given. But these things are not given like that. Now I'll say that, sir, we can say that one more formula is there. Tan of beta minus alpha 0. Do you know that? From the merchant circle diagram, directly from that diagram. Tan of beta minus alpha 0 is exactly equal to FC divided by FT. Do you know that? Yes, sir. Alpha 0 is 0. Rake angle is what? 0. So I'll put value of alpha 0 is exactly equal to 0. So can I write down here tan of beta is exactly equal to cutting force. Sir, cutting force is given exactly equal to 1200 Newton. Thrust force is 800 Newton. So I'll say 1200 divided by 800 Newton. And can I say that, sir, we have to calculate friction angle beta here, and then we have to calculate coefficient of friction. But sir, there is a relation between them. I don't require to directly calculate. So can I say that, good evening, I have done too. So I'll say that, sir, mu is exactly equal to tan beta. No problem at all. Is it true? Yes. So can I say that 1200 divided by 800? So 0, 0 will get cancelled. So it will be exactly equal to coming 3 by 2. What is the answer is coming? 3 by 2. Is it coming 3 by 2? Yes. So can I say that, sir, it is coming, sorry. It has to be Ft by Fc. Is not, you have to tell me that, na? Ft by Fc. Ft by what? Fc. So it has to be coming as, 800 divided by 1200. So it is coming what? 2 by 3. 2 by 3 would be answer is coming. So C is exactly equal to spot on answer. What is that? 2 by 3 would be answer for me. Is it okay? Yes. Simple question was asked. Calculate what? Calculate what? Coefficient of friction. Next question. On the same, calculate the cutting power in the watt. For the same question in continuation, calculate cutting power. Everybody, sir, if I want to calculate power, can I say that, sir, formula of the power is very simple. Sir, we know that power is exactly equal to cutting force Fc into Vc. And what is meant by power? Rate of consumption of energy is called as power. So cutting force is what? 1200 Newton. Right, fine, it was given. And cutting velocity, what is cutting velocity? It was given in the problem. Cutting velocity is 60 meter per minute. It is what? 60 meter per minute. So I'll write down 60. Should I put it in 60 meter per minute? Only 60 meter per minute? Because we know that power has to be rate of consumption of energy. That is Newton into meter is joule. Joule per second. So we have to convert this meter per minute has to be meter per second. So we have to divide it by 60. So answer will come 1200 joule per second. That is exactly equal to watt. That is exactly equal to what? Watt. So how much answer? Bombay B. Absolutely correct, Sandeep. So Bombay B is exactly perfect answer for that. You have to calculate this, right? Fine. Every fundamentals is going to revise here. So I'll say that, sir, answer is what? 1200 watts, joule per second. Sometimes students use it as it is 60, but it is not a correct answer. Calculate the length of the shear plane. What is the length of the shear plane, sir? This is the angle made by shear plane with cutting velocity vector. That is what shear plane angle phi. This is uncut chip thickness T0. And this is nothing but called as length of the shear plane LS. Multiple times we have discussed this. Now we are interested to calculate length of the shear plane. So use the sine rule there. So I'll say sine of phi, that is shear plane angle phi, is exactly equal to T0 divided by length of the shear plane. Length of the shear plane. Please calculate the length of shear plane and tell me that. Without that, leave the session, go and do something if you don't calculate it. As simple as that. Kiran, Sandeep and rest of the students. So I'll say that very simple, sir. Length of the shear plane we have to calculate T0. So uncut chip thickness T0. So what is the value of uncut chip thickness? Sir, uncut chip thickness T0 is given 2 millimeter. So I'll write down 2 millimeter here. 2 millimeter, right, fine. Divided by sine of phi. How much is shear plane angle phi? Sir, phi is given 30 degree. So I'll put it there 30 degree. So I'll put it there what? 30 degree sine of 30 degree. So length of the shear plane is coming. How much answer is coming? Length of shear plane? Anyone? Anyone calculated length of the shear plane there? No one has calculated length of the shear plane. Is there anyone who has calculated length of the shear plane? The answer is coming exactly equal to 4 millimeter. So Delhi D is perfect answer for this. 4 millimeter, very correct. Sandeep, very correct. Kiran, very correct. Right, 4 millimeter is the length of the shear plane. Right, next question. A single point cutting tool with a 60 degree rake angle. What is a rake angle? 6 degree. Is used for orthogonal machining for a ductile material. The shear plane angle for theoretically minimum possible shear strain. What is that? Shear plane angle. Shear plane angle means what? Angle made by shear plane with cutting velocity vector. Phi we have to calculate, right? And for what? Theoretically possible minimum shear strain. Minimum shear strain. There is one condition in a metal cutting sheet metal operation or metal cutting chip formation. Minimum shear strain. So minimum shear strain condition. You tell me that. What is it? So minimum shear strain is exactly 2 phi minus alpha is exactly equal to 90 degree, right? This is the condition to satisfy minimum shear strain. So now alpha value, rake value is given. What is alpha value? It is 6 degree. It is what given? 6 degree. Absolutely correct, Kiran. 48 degrees, right? So I'll put it here. 2 phi minus 6 degree is equal to 90 degree. We are interested to calculate phi. So how much coming it is? 48 degree. So therefore, I'll say that A would be a perfect answer for this 48 degree. This question was asked in examination, or this question, some different format of question was asked. Is it correct? 48 degrees. Sandeep Reddy, correct. Kiran, Sandeep, and Anabhav. Yes. Next question. Tool life is generally specified by. How the tool life is specified? So we know that there are multiple ways available by which tool life can be specified. So we know that the tool life is specified by 3 ways. Actual machining time between 2 successive regrinds, it is mentioned in the time. Then how many number of components we manufacture between 2 successive regrinds, that is called as a number of components produced in a mass production. This is the number, there is no unit. And the next, volume of material removal takes place between 2 successive regrinds for a large component to get manufactured. These are the 3 ways, and it is mentioned in what? Millimeter cube, how much volume is removed. So therefore I'll say that, sir, number of pieces machined, yes, this is the way by which it is represent. Volume of material removed, yes. Actual cutting time, yes. So all of the above is there. So can I say that answer is what? Any one of the above is my answer. This is what exactly my answer is. What is that? Delhi D is my perfect answer. Delhi D is my perfect answer. Is it correct, Kiran? Yes, Delhi D is my perfect answer. Sandeep, Kiran, perfect. Right? Fine. Next question. While turning a 60 mm diameter bar, there is one bar is given. 60 mm diameter of the bar is 60 mm. It was observed that the tangential cutting force was 3000 Newton. What is the tangential cutting force? 3000 Newton. And the feed force was 1200 Newton. Feed force is given and cutting force is given. Great. If the tool rake angle is 32 degree, rake angle of tool is 32 degree, then the coefficient of friction is nearly equal to. How much will be a coefficient of friction in this particular case? Can I able to calculate coefficient of friction in this particular case? You just tell me and calculate answer. Sir, if I write down the data here, you'll understand what kind of data is given. Based on that, you can judgment that. Sir, cutting force is given FC, that is 3000 Newton. 3000 what? Newton. Very correct. Now the thrust force is given. How much is answer? 1.36. Absolutely correct, Kiran. Superb, man. So I'll say that thrust force is given exactly equal to a 1200 Newton. Right, fine. And the rake angle of the tool alpha, that is orthogonal rake angle, obviously 32 degree. And we are interested to calculate what? We are interested to calculate a coefficient of friction. Coefficient of friction, that is exactly equal to mu value we have to calculate. Mu value we have to calculate. But sir, calculation of coefficient of friction has simple one. Either you calculate friction angle beta, or you calculate friction force or normal force, then only you could be able to calculate a coefficient of friction mu. Because we know that, sir, mu is exactly equal to either I'll say tan beta, right? Or I'll say that, sir, it will be friction force F divided by normal force N. Friction force F divided by normal force N. Right, fine. So until unless I don't know either of the value, I can't be able to calculate answer. But sir, if you know cutting force and thrust force are given, in the orthogonal cutting, analysis of orthogonal cutting operation, we have developed certain relation between what? The friction force in terms of cutting force and normal force, the inverse of thrust force, and normal force in terms of what? Cutting force and thrust force. So if you go back and you'll see that determination of forces, there is a lot of derivation is done. So here we have written here and develop a relation. You can go and check that. What is the relation developed? F is equal to, friction force F is equal to what? Fc into sine of alpha 0 plus Ft into cos of alpha 0. Is it true? Yes. So we have to write down here Fc into cos of alpha 0 plus Ft into what? Ft into sine of alpha 0. These are the derivations that you have to understand, that you have to remember. Next, what is the formula? N, Fc into cos of alpha 0 into minus Ft into sine of alpha 0. So I'll say that it will be Fc into cos of alpha 0 minus Ft into a sine of alpha 0. Do you remember these formulas? Because my dear friends, the get rank and the success is not easier, right? Fine. Don't waste a valuable time of your life, right? If you want to do it, that you have to do it seriously. It's very serious concern. So, right, cutting force kya hai? Sir, I know the cutting force is 3000 Newton, thrust force is 1200 Newton, and alpha is 32 degree. You put the value, alpha 0 is rake angle, or alpha is rake angle. And once you calculate that, mu is coming exactly equal to 1.37. How much it is coming? It is coming 1.37. This is what exactly my answer is. So, I'll say that Bombay B is my proper, answer is A. Answer is what? A. Is it true? If I don't remember this formula, this numerical can't be solved. If I don't remember this formula, this numerical can't be solved. Do you understand that? This numerical can't be solved. We have to go through this derivation. It is developed and covered into the theory lectures, right? The determination of cutting force and thrust force in terms of friction and normal force, and vice versa is also there, right? Fine. I hope so you understand that formulas. This is not the session to discuss this. Next question. Very interesting question. Everybody kicking and alive. Right, fine. During the formation of chip in machining with a cutting tool, which one of the following relation holds good? Now we know that, sir, there is a one particular relation is there based on a triangle of velocity. That's called as velocity triangle. And we are applying sign principle to there. It was given that V is nothing but cutting speed, Vc is nothing but the velocity of the chip, Vs is the velocity at which the shearing takes place along the shear plane, Phi is the shear plane and alpha is the rake angle. Tell me which one is the correct one, A, B, C or D. So we have to go for that particular sign triangle or a velocity triangle. So how much are the velocities? Yes, sir, that. Sir, cutting velocity, velocity of tool with respect to tool. This direction what? Cutting velocity is there. Vc, right, fine, cutting velocity. The shear plane along which shearing takes place. The velocity of the chip along the shear plane, that is called as shear plane velocity Vs. And along the surface chip is flowing, that is called as chip flow velocity Vf. And then these angles, you can go and calculate these angles. Right, fine. And if I apply this particular velocity triangle theory, sign theory, we'll get this relation. Vc is equal to cos of phi minus alpha 0 is equal to Vs is exactly equal to, or Vs by cos of alpha 0 is equal to Vf by sin of alpha 0. And everybody aware of that thing. This is not a rocket science that we are speaking about, because you need only question and the solution of that. And everybody is aware of that. What exactly sign rule and sign principle in the metal cutting operation is there. Now here what is given, only change is there. V stands for a cutting velocity. So I'll say V divided by cos of phi minus alpha 0, right, is equal to Vs is the shear plane velocity. It is same Vs, that is exactly equal to sin 90 minus alpha 0 means what? Cos of alpha 0. We can say that cos of alpha 0 is equal to V up. So V up is chip flow velocity. What is chip flow velocity? It is given Vc is the velocity of the chip. So we'll write down here Vc. Only change is there, and sin phi below that. So if I come back here and if I check it here, I'll say that A is the perfect answer for this. V by cos of phi minus alpha 0, Vs by cos of alpha, and Vc by sin of alpha. Is it okay, everybody? Yes. This question is very important, right? Theory question hai, but it is based on fundamental. Based on what? Fundamental. I hope so you are understanding this. A is correct answer, everybody. Thumbs up. Yes. Great admirer, Ranjit. Thank you, Ranjit. Yes. Fine. Next question. Now we are talking about in a machining test. In a what machining test? A cutting speed of 100 meter per minute indicated the tool life as 16 minutes. And a cutting speed of 200 meter per minute indicated the tool life as 4 minutes. The values of N and C. So that means we are interested to calculate tool life constant or Taylor's constant and Taylor's exponent. Because Taylor's tool life equation, what is the Taylor's tool life equation, sir? It's very simple. Taylor's tool life equation is V into T to the power of N is exactly equal to C. That is what exactly value is there. This is what exactly Taylor's tool life equation. Now there are two different conditions are given. So when the cutting speed is 100 meter per minute, my tool life is 16. And when it is increased to 200 meter per minute, my tool life is 4. So put the value there, same metal conditions, same metallic conditions, same tool. So constant will remain constant, right? Fine. So I'll say that for first condition, I'll say that V1 cutting velocity is 100 meter per minute, 100 meter per minute, and the tool life, that is T1, is exactly equal to 16 minutes. You have to calculate answer, my dear friends. What is the answer? 0.5 and 400. Kya baat hai, Kiran? Love you all. Love you, boy. Okay, fine. Apply what? Apply the Taylor's tool life equation, sir. 100 multiply by 16 raised to the power of N is equal to C. You say this will be my equation number 1. What will be equation number 2? I'll directly write down equation number 2 for this particular case. What will be, sir? Cutting velocity 200 into tool life 4 raised to N exactly equal to C, equation number 2. Can I say that as the cutting condition remains same, tool material remains same, so right hand side constant will remain same. Can I compare equation 1 and 2? So by comparing equation 1 and 2, I'll say that, sir, 100 into 16 to the power of N is equal to 200 into 4 to the power of N. Is it accepted? Is it accepted? Harish Kumar, yes, absolutely correct. Sir, we have to calculate N. If you calculate N here, answer is coming 0.5. Right? Half the story is done. And such kind of so many numericals are there in every year. And we are just panicking, sir, get examination. What What the hell, the GATE examination is very simple. But if you are ready to take challenges and ready to work, I hope so everybody is aware, sir, of C value, N value calculated. You put in any equation, either first and second, put the N value, calculate C. So I'll put it here because this is on the screen. So I'll say that, sir, 200 multiply by 4 to the power of N, that is 0.5, is exactly equal to C, and C is coming exactly 400. Can anybody tell me what is the unit of 400? Is it a numerical value, 400, constant hai to 400? Or is there any unit? Meter per minute, because it is a cutting velocity for a 1 minute tool life. Is it okay? Yes, superb, superb. So my answer is N is equal to 0.5 and C is equal to 400. C is my answer. Kya baat hai, bravo, bravo, bravo. Okay, if there is 2 students are there in the class, but they should be reactive. They should solve the numericals. That's what we want. We want to save the time. We want what? The full fruitfulness of this particular time. Okay, okay. Next question. Flank wear occurs mainly on the, where the flank wear occurs. Sir, what the silly question is? Flank wear has to occur on the flank surface. There are 2 types of wears. What is that? So one is crater wear, one is flank wear. What is the crater wear? So wear takes place on the rect surface. Ye rect surface hai, this is the rect surface. Wear takes place on the rect surface is called as crater wear. And wear takes place on the flank surface. This is the side flank. This is end flank. That is front flank also. We can say that. Which one? Which one? Sir, this will be exactly equal to which one? OMG. Sir, this will be my end flank. This will be my what? End flank. End what? Flank. And don't look at me that what is flank means. Everybody aware what is flank, right? Fine. So this is my side flank. Is it so? Yes, it is my side flank. So whenever the wear takes place on the flank surface, it is nothing but called as what? The flank wear. So now option is nose part of the particle. No, sir. Face of the cutting tool. Face pe nahi. Face pe which particular? On the face, crater wear. Face is nothing but called as rect face. But the Bombay B or second option, they go front relief face and the side relief face. Relief is nothing but what? Clearance. Clearance face. That is nothing but flank face. So only 2 is correct answer. Only what? 2 is correct answer. Is it true? Yes, only 2 is correct answer for me. This is $1 million answer. This is $1 million answer. Why I selected theory question also? Because it is also part. And theory questions require the biggest fundamentals. Kiran, very correct. C. Is it true? Yes, absolutely correct. Next. The purpose of providing side rect angle on the cutting tool is. Why do we provide side rect angle? If I produce side rect angle 0 or if I don't provide side rect angle. Now students will ask me that, sir, what is side rect angle? If I go and technically speak about this particular figure, will give me all the angles here. What are the angles, sir? This is all explained. Sir, in this particular figure, you say that this is the side face. This is rect face. The rect surface, inclination of rect surface towards side. This is the length of the body. This is the side. So this angle is nothing but called as what? Side rect angle. Alpha S. Alpha S. Back rect angle bhi hai wahan pe. So can I say that over that rect surface, who is flowing? The chip is flowing towards side direction because this is my cutting edge. This is my cutting edge. Which one is my cutting edge? Sir, this is my cutting edge. This is my cutting edge which is engaged with respect to workpiece and chips start flowing. Chips start what? Flowing. So can I say that whatever this inclination of the rect surface towards slide, inclination of rect surface towards side, what it will control? What it will control? It will control the chip. It will control the flow of the chip. Yes. So is it controlling and avoid the work from the rubbing against tool? No, sir. Avoid the rubbing of the tool against the work. Clearance angles are provided. Clearance angles are provided. Strengthen the tool edge. No, it is not strengthening the tool edge. Tool edge somewhere else. Right, fine. Break the chip. It is not protecting against that. It is what? It is control the chip flow. It is controlling what? Chip flow. Is it accepted? Yes. Is it accepted? Yes. Many competitive examination. Many. Are you only preparing for GATE? Whatever examination there on the planet you should appear. Why you bank on only that GATE examination? Right? We are ready to bank on every examination. Is it true? Bombay B is correct one. Kiran Kumar. Yes, absolutely. Right. Next question. In front of you only. Very simple. Sir, if N, Taylor's exponent 0.5, constant 300 for the cutting speed and the tool life relation. When the cutting speed is reduced by 25%. Now what I am doing? I am just reducing the cutting speed by 25%. Okay. The tool life will be increased by. How much percent by which tool life will increase? Sir, again it is a comparative type because material of the tool same, material of the workpiece same, material cutting conditions remain same, constant remain same. Right, fine. So I'll do one thing that whatever first condition is there, for first condition we'll apply Taylor's tool life equation. For second condition also we'll apply Taylor's tool life equation. We'll compare, we'll calculate. Is it accepted? Kiran Kumar, Bombay B or calculate and tell me answer. Sir, I'll just write down. Simple story. Kya hai bhaiya? Sir, small n. How much it is? 0.5. And C constant. How much it is? 300. Okay, no worries. Right, fine. What is Taylor's two-life equation? V1 into T1 raised to n is exactly equal to C. Instead of that, I'll write down V1 into T1 raised to n. Instead of T1, you write on 0.5. Write on 0.5 is exactly equal to C. What is C? 300. You put it and set as equation number 1. Now what happens in next stage? The cutting speed reduces by 25%. If the cutting speed reduces by 25%, how much it will remain? Reduction हो गया भैया 25% से. बचा कितना? How much remain? Sir, it will remain 75. So can I say V2 will be 75.75 times the velocity V1? And we are interested to calculate Taylor's two-life equation in the second case after reduction of the cutting speed. Okay, no worries. So I'll put the equation here. V2 into T to the power of n is equal to C. Instead of V2, I'll say 0.75 into what? V1 into T2 to the power of n. That means 0.5 is equal to 300. Equation number second. Equation number second. Is there anyone who calculated answer? Is there anyone who is calculated answer? Kiran, Ranjit, all the students are there. Who is there? What? Sandeep. Sir, अब क्या है? Compare कर दो यार. Compare both these two equations and calculate answer. What's the big deal in that? Right? We are about to score All India rank 1. And these silly questions you don't ask us. So if I compare that, I'll say that left hand side 0.75 into V1 into what? T1 to the power of 0.5. Sorry, T to the power of. This is what? T to the power of 0.5 is exactly equal to V1 into T1 to the power of 0.5. Is it true? Yes. Now I'll get very correct, Kiran. Absolutely spot on. 77.77. Now I'll get a relation T2 exactly equal to some number into T1, and that number is 1.77777 like this. This is what exactly ultimate relation you will get it. That is what the T2 to life is 1.77 times T1. T2 to life is 1.77 times T1. That means, can I say that T2 to life is greater? T2 to life is greater because that factor by which I am multiplying that Taylor to life T1, it is greater than 1. So cutting life to life has increased by how much percent? The 2 that is increased by how much percent? Can I say that it is increased by 77.7%? 77.7%. If that value could have been less than 1, the value could have been less than 1. If it could have been less than 1, then what will happen? Then to life must have been reduced. Right, fine. So if you go back, what is my answer? Darling answer is 78, which is the closest one. Which is the closest one. Is it true? Are you able to solve, everybody? Are you able to? देखो भैया, अगर उसूलों पे आए बात, अगर उसूलों पे आता है भिड़ना जरूरी है. अगर बात उसूलों पे आता है तो भिड़ना जरूरी है. अगर जिंदा है तो जिंदा दिखना भी जरूरी है. Human life and the human body has the emotions. We smile, we cry, we yell, we argue, we comment, right? As simple as that. If you are there in the list, why are you watching this if you are not solving? Go back and do interesting things. Yes? Okay, next question. You have to solve. In an orthogonal cutting operation, very interesting question. In an orthogonal cutting operation, the shear angle is 11.31 degree. Shear angle is represented by phi. Okay. Cutting force FC. Cutting force FC. The thrust force FT. Thrust force is what? FT. Then the shear force will be approximately. So how much will be my shear force? How much will be my shear force? Approximately. How much my shear force? I told you that there is a one chapter which is nothing but called as a orthogonal. That is nothing but called as what? The analysis of a orthogonal machining operation. And there are so many relations that we develop. Without these formulas, these chapters and the numericals cannot be solved. If I want to calculate shear force, do you know the relation between shear force in terms of cutting force and thrust force? Yes, sir. There is one magical equation is there. What is it? Shear force is exactly equal to cutting force into a cos phi minus ft into sin phi. Yes. From where? Derivation. From where? Derivation. From where? Fundamentals. These fundamentals you can check. Shear force Fs is equal to Fc into cos of phi. Fc into what? Cos of phi minus ft into what? Sin of phi. Have you heard about this? Have you heard about these particular equations? You have to heard. You should, right? Fine. So put the value there. So I'll say shear force is equal to cutting force. Cutting force kya hai? 900 into cos of phi. How much is cos of phi? Phi is 11.31. That is given. Minus Ft, that is thrust force. Sir, how much value? 810 Newton it was given, into sine of phi. How much it is? 11.31 degrees. So how much shear force is coming? Anyone calculated shear force? Anyone calculated shear force? Dekho bhaiya, these are fundamentals. Honestly speaking, you have to put your blood and sweat to understand that. We are not talking about 11, 12 or any Tom, Dick and Harry. You have to choose your God very wisely, because you have to crack the GATE examination. It's not that in a YouTube session I have to make you happy. And once you go, sir, wah, 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 rank is 0, dabba. It's not accepted. Come on. Right? So choose your God very wisely. You need to understand. 723, kya baat hai? Kiran Sandeep Reddy, superb man. Sir, 723.66 Newton. Reality is reality. Shear force is equal to this much. Shear force is equal to this much. That means it is closer to 720. This is my answer. This is my answer. No doubt into it. Are you accepting, everyone? How beautiful questions we are solving. Right, next question. In an orthogonal turning operation, the chip thickness is 0.32. Feed is 0.2. Then the cutting ratio will be, how much will be a cutting ratio? How much will be a cutting ratio? Tell me. Now this answer at least tell me that. 5 students at least tell me what is this answer. 5 students at least has to tell me what is exactly this answer is. Is it true? If you like the session, you will press the like button, mark the presence, spread among the students so the rest of the students will also join. Right, it will be beneficial to you only. Sir, you talk about cutting ratio. I know that cutting ratio is a reciprocal of chip thickness ratio. What is it? We'll say that, sir, a cutting ratio is exactly equal to reciprocal of chip thickness ratio 1 by R. R is chip thickness ratio, that is T naught divided by TC. T naught divided by TC, uncut chip thickness divided by thickness of the chip, right? Uncut chip thickness divided by thickness of the chip. What is uncut chip thickness? It is given thickness of the chip. What is that? TC 0.32, and feed is given. But when the feed is given, feed has to be considered to what? Uncut chip thickness. There are certain rules are there. How to select it? There are 3 rules. What is that? Sir, things to follow while solving numericals for deciding uncut chip thickness T naught and the width of the chip B. So when depth of cut is given, let's say that feed is given and depth of cut is given. If inclination angle I is 0, lambda is 90 degree, in that case, the uncut chip thickness or feed becomes uncut chip thickness and the width of the cut becomes, depth of the cut becomes width of the chip. That you need to understand. There is second parameter. When the depth of cut and width of cut is given, depth of cut and width of cut, formula, you can remember that figure. When depth of cut and width of cut is given, depth of cut becomes uncut chip thickness, width of the cut becomes width of the chip. Width of the cut becomes width of the chip. And the next one, if feed is given and the width of the cut is given, so feed becomes uncut chip thickness and width become the width of the chip. Is it true? Now you will say that, sir, what the hell you are speaking about? And answer is 1.6. Very correct, Sandeep. Right, fine. So I'll say that what is the answer is coming? T naught. T naught is what? 0.2 divided by what? TC, that is 0.32. But we require 1 by R. If you calculate 1 by R, you'll get 1.6. 1.6. So this will be my answer. 1.6. Now you tell me that these are all the fundamentals, that whatever I'm showing you, is it possible to tell you in 10 minutes? Or 2 minutes or 1 minute? Now zamana TikTok ka chal raha hai bhaiya. What is the age is going on? TikTok. The expectation of student is that only in that session entire production should be there in the heart. All India rank 1. कैसे आएगा भगवान जाने. लोग भी क्या कर रहे पता नहीं. जमाना कहाँ जा रहा है, we don't know. Yes, life. Right. Real balls are not there. The most important function of the cutting fluid is, now at least tell me this answer. What is the most important function of the cutting fluid? Cutting fluid की बात कर रहा हूँ. Is it providing lubrication or cool the tool and the workpiece or wash away the chips or improve the surface finish? What is your answer? What exactly is the main function? A, B, C or D? What is the main function of the cutting fluid? It was clearly mentioned that the most important function, tell me. Is there anyone who can correct and answer this? What is the most important function? Why we provide that cutting fluid? Sir, most important function of the cutting fluid is lubrication is wrong answer. How we can lubrication ke liye there is a lubricant provided. The first function, the most important function of a cutting fluid is to cool my workpiece and cool my tool. That is nothing but cool the tool and the workpiece. Then also it is providing the other function also. What is that? Providing lubricant or wash away the chips or to improve the surface finish. But these are secondary. What is the primary? What is primary? Primary is what? Primary is to cool the tool and the workpiece. Carry away heat. Heat is causing a lot of problem. So carry away heat. Is it understood? Most important function. If I say lubricant, so most important function of lubrication or lubricant is to provide lubricant. But is it mentioned lubricant? No. Cutting a fluid. Cutting a fluid. Is it understood? Bombay B, Bombay B. Samir Reddy, Kiran. Is it true? Yes. Okay. In Taylor's true life equation, now you tell me the answer of this. In Taylor's true life equation, V into T to the power of N is equal to C. Okay, fine. The constant N and C depends on whether they are depending on workpiece material or tool material or coolant. 1, 2, 3, 1, 2 or whatever it may be. A, B, C or D. Tell me answer. Okay, Sandeep, I want answer from you. Sandeep, Kiran and Abhi to Manu, something like that. Right? Okay, A is answer. Oh my God, superb, superb, sir. Very true. When we talk about N, N is nothing but called as Taylor's exponent, and that is depending upon tool material. Is it accepted? Yes. Tool material is changing, or this value is going to change. Is it true? Yes. And C is nothing but called as Taylor's constant. It depends on tool material, it depends on workpiece material, it depends on coolant, it depends on working conditions and the machining conditions. So it depends on all the things. It depends on all the things. So it depends on all the things. That means in a joint and collectively, small n and capital C depends on all the three things. 1, 2 and 3. 1, 2 and 3. So I'll say 1, 2 and 3. So my answer is A. My answer is what? A. It depends on what? All the things. Very correct. Kiran, Sandy, superb. Working conditions. Yes, working condition means what? Working condition matlab temperature ho sakta hai. Lubricants use, lubricants not use. That can be also considered as working conditions. Coolant use, coolant not use. Called as what? Machining conditions. Right? Fine. Next question is in front of you. In orthogonal cutting operation, the cutting velocity is 40 meter per minute. The chip velocity is 20 meter per minute. If the rake angle of the tool is 10 degree, these values are given. What is given? Cutting velocity. Oh, super. Chip velocity. My mind blowing. Shear angle is. Calculate the shear angle. Most basic question asked in a GATE examination. Multiple times. You open the last 10 years papers and you'll see that so many flooded of question. And simple data is given. Now I have chosen this data. 40 is the cutting velocity and the chip flow velocity is 20. Rake angle of the tool is 10 degree. That is called as orthogonal rake angle. Oh my God. And then calculate shear angle. Come on. Sir, now you don't ask me. I am a master in this, right? Cutting velocity, VC, 40 meter per minute. Okay. Chip flow velocity, VF, how much? 20 meter per minute. Rake angle of the tool, alpha 0, 10 degree. Alpha 0, 10 degree. Is it okay? Everybody? Yes. Do you remember one basic? Oh my God, 28.334. Superb. That's called real power. Power hai ye. Superb. Okay. Sir, are bhaiya, humko pata hai bhaiya. There is one formula. What is that? Tan phi is exactly equal to R into cos of alpha 0 or alpha divided by 1 minus R into sine of alpha 0. Right? This formula is there in the blood now, right? 1 minus R into sine of alpha 0. Sir, what is R? Chip thickness ratio. T naught by TC. But chip thickness ka kuch thickness diya hi nahi. But there is a one additional formula is given, value is given. What is that? Chip flow velocity VF and VC. Can I say that? There is also relation. VF by VC is chip thickness ratio. VF is 20. VC is 40. Chip thickness ratio is 0.5. Chip thickness ratio is 0.5. Superb. So now I'll say that tan phi. Kitna aega tan phi? So tan phi is equal to R. What is that? 0.5 into cos of alpha 0. What is that? Cos of 10 degree. Divided by 1 minus 0.5 into sine of alpha 0. That is what? 10 degree. That is what? 10 degree. Okay. Super. Bloody hell. Answer of phi. 28.33 degree. 28 point what? 33 degree. Super. Killing. Kiran, Sandeep, killing. Working conditions, killing. Right, fine. 28.33. Right. Get the answer and get the All India rank. Get the job. Right. And work in an entire life like me. Right. Okay. Is it okay, everybody? Yes, shear velocity with the help of velocity triangle. Now there is one more question asked, link answer question. It can be considered as a linked answer question. What is that? Shear velocity with the help of velocity triangle. Shear velocity with the help of velocity triangle. So we are interested to calculate Vs, that is nothing but called as shear velocity with the velocity triangle. Can you able to calculate? Yes sir, if I go to the velocity triangle, you'll get the number of relation. What is that from here? Sir, we are interested to calculate Vs. Anyway, what is that? Shear velocity. From here, can I say that shear velocity Vs divided by sine of 90 minus alpha 0, that means cos of alpha 0, is exactly equal to, what is that now? Vc, I'll take Vc or Vf. I'll take Vf, right? Vf divided by opposite of what? Phi, that is exactly equal to sine phi. So that means, can I say that Vs is exactly equal to Vf into a cos of alpha 0 divided by a sine of phi. Sine phi. Phi just now we calculated. All the values are there. Alpha 0, rectangle. How much it is rectangle? 10 degree. Is it what? 10 degree. Okay, fine. Vf is given to you. Vs we are interested to calculate. Phi 28.33 degree. And if we calculate, that answer is coming what? What is coming shear plane velocity? You tell me that. If I go and check that shear plane velocity, it is coming exactly equal to, Vs is coming exactly equal to, how much it is? 41.5. 41.5 meter per minute. Meter per minute. Don't forget the units. Units are very important in the life, right? What? 41.5. 41.49. Absolutely correct, Kiran. Delhi D is spot on. Delhi D is what? Spot on answer. Is it okay? Yes, superb. Right, next question. It is waiting for you. Superb question is there, which is waiting for you. A single point right-handed turning tool. Single point right-handed turning tool is used for a straight turning. The feed is 0.25 mm per revolution and the uncut chip thickness is found to be 0.25 mm. The inclination angle of the main cutting edge is 10 degree. The backrake angle of the tool is. Backrake angle. What is backrake angle? Alpha B. What is backrake angle? Alpha B is question mark. Inclination angle I is exactly equal to 10 degrees given. What is given? The feed F 0.25 mm per revolution. Uncut chip thickness T naught is exactly equal to 0.25. Can somebody tell me directly answer? You direct answer, conceptual. Direct answer. Is there anyone who's there in the hall, in the town, can directly tell me answer? What is answer? T naught 0.25. Feed 0.25 mm per revolution. So that means, can I say that the feed is become exactly equal to uncut chip thickness? Feed is becoming exactly to uncut chip thickness, right? There is no sine lambda or something is coming. So which means that lambda value is 90 degree. Lambda value is what? 90 degree. And side cutting edge angle is exactly equal to 0 degree. Side cutting is what? 0. Lambda is what? 90 degree. Conceptual hai. Conceptual. Here approach angle lambda kitna hai? 90 degree. Side cutting edge angle CS is exactly equal to 0. And if it is so, can I say that these two planes are going to overlap to each other now? That means that whatever the longitudinal axis, can I say that this is my longitudinal axis and this is exactly equal to my transverse axis, right? This is nothing but called as my XX, longitudinal axis XS, which are used in ESE system of tool geometry. This is the transverse plane, right? Transverse plane and longitudinal plane, and they will be going to coincide with the cutting plane, orthogonal plane. So can I say it will be called as orthogonal plane pi O, which is normal to cutting edge? Normal to cutting edge, and this pi y will be nothing but called as pi c, that is cutting plane, because it is coinciding to the cutting edge, right? If it is so, can I say that this is the inclination angle I? Inclination angle means what? Angle made by rect surface with the reference plane along the cutting edge. That means this is my inclination angle. This is inclination angle. I'll say that, sir, how? This is how. Inclination angle, right? So now if these angles, this is what exactly cutting for, or sorry, the transverse plane and the cutting plane are coinciding, that means, can I say inclination angle I is exactly equal to backrake angle alpha B is exactly equal to 10 degree. Inclination angle I is exactly equal to the backrake angle alpha B is exactly equal to 10 degree. Isn't it or not? Fundamental, that's why I told you that without fundamentals we can't able to solve. Fundamentals are the key everywhere. Fundamentals are key. You have to put your blood and sweat. You have to understand that. And in this figure, you can say that cutting plane, orthogonal plane, inclination angle, side view also it is given, inclination angle, the tool is also there. Tool is also there, not 90 degree. It is exactly good. Backrect angle and what? Inclination angle will be same. Because my cutting plane and the transverse plane are coinciding. Cutting plane and the transverse plane are what? Coinciding to each other. Coinciding to each other. Because my feed and uncut chip thickness both are same. And when the feed and uncut chip thickness is same, that means approach angle lambda 90 degree. Or side cutting is CS is exactly equal to 0. Is exactly equal to what? 0. Is it understood, everybody? Is it understood? So these 25 questions roughly in a very quick and rapid fire manner we have covered. Very quick and rapid fire manner we have covered. Now if you have any doubt, you ask me that. If you have any doubt, you just ask me that. Or if you need anything from tomorrow, we have 3 to 4 topics. Milling, drilling, lathe machining and the shaping. From that territory, we'll come up with again some problems. I don't know how much it will help, but we'll come up with the problem and let's see that how the students will get benefited from that. But before coming here, there is one prerequisite. And what is it? It's very important that you should go and brush up your knowledge and then come down and sit, right? That's also important. If you are coming to the joining this, Kiran and the rest of the students, right? Whatever questions we have solved, are you understanding this? Yes or no? Write something so that I'll understand. Okay, but compared to yesterday, students are more active today. I'm very happy. At least there are few students who are interacting and they are putting answers like that. I'm very happy for that. Sandeep, Kiran and rest of the students, Sandy. Right, fine. Which type of questions you like to solve? Which type of questions? Theoretical questions or numerical one? And how many numericals that you want? You also tell me that. If you want more numericals, we'll come up with more numericals. Or it should be a bunch of combination of both, theory plus numerical. That should be a better option, I guess. Because machining is very vast topic as such. Machining is what? Very vast. It's a very vast topic. So many topics are there. It need to be dealt with a very detailed manner. So in tomorrow's 1 hour session, we'll try to justify that particular session. We'll see that. Yeah. Murugasen, very thank you. Kiran, yeah, both will try to cover now, right, fine. So thank you everybody for joining the sessions, and tomorrow we'll be having one more session. If you prepare, then come and join the session, and then again we'll try to solve 25 questions. It will be like a refreshing session, it will be like a revision session or a practice sessions to you, and you can check your knowledge also whether I belongs to that Manhattan or not, what exactly this man is speaking, that also you come to know that, right, fine. And if you want to cover me some topics on the free YouTube sessions like metal cutting or some metal forming or casting or welding, that will be also welcome. There is one particular, I would say, a Telegram channel is also there. So I'll put this PDF on my Telegram channel so that you can go and download that PDF so that you'll get an idea which questions and what exactly. My name is Ravindra Thube. So you just can go and basically join my Telegram channel also. There is no problem at all in this particular case. There is no problem at all in this particular case. Is it okay? Yes. So on this particular session, we'll take a leave. We'll take a leave. Let's take a leave today, and then again tomorrow we'll come and meet you again. Right? Fine. So thank you everybody. Kiran, Sandy, Murugasen, and rest of the students. Tell the rest of the students also there are beautiful things are going to happen. Right? Right, casting, sir, Sandeep, yes, casting will cover in YouTube session, that's the demand, and welding also. Next month we'll definitely try and plan this, basically. I know that in the previous organization also that is a bit of issue, I'll try to cover it, right. Tell the rest of the students that we are conducting best of the session, so let the students frequency match to me, so that we'll be having the blast. And you can join my Telegram channel, and I will provide the PDF of today's sessions in that particular channel, right? So keep smiling, keep believing, keep walking. Bye-bye, right? Thank you, everybody. See you tomorrow. Right, thank you. Take care.